Hello and welcome back to High Fell. As you can see on the coaster of loveliness today, we have a TT 120 made by Hornby Class 50. This particular one is 50020 Revenge, which of course is a renumbered version of the ones that are available. So if you can have multiple ones, this is actually a really easy thing to do. Those came from RailTec. It is an absolutely superb. It's actually it's a 3D print. It's not 3D printed, but a 3D print transfer, and these are actually fantastic. There's various people that do etched ones. I also use silver tape for getting etched nameplates, but these work really well and very easy to do and apply. But that's not the reason why we're actually looking at that today. It is the self-ejecting Cardan shaft, drive shaft, call it as you will. It's something which has affected some of the Class 43, which others will know as a high-speed train or a 125, and also on the 50. Hopefully Hornby have got their engineering elves working hard on what they're going to be doing for the forthcoming things like 66, etc. But for the purpose of this, I have been testing some quite snazzy products from This Way That Works. Richard's been working hard and putting his engineering brain to a great deal of use, been chatting quite a lot about this, and something quite different to show you. So these are being run on the Class 50 and also the 43, over 10 hours running, not so much as a slight idea that anything is going to go skyward on these. So what I'm going to do is I'm going to pop the body off this. You've seen that loads of times, so I'll do that off camera and then we'll come back and I'll show you inside what's been done and how you can transform your locos. Okay, we're in. So looking at this, if I can get that into the light, there we go. You can see it's a very different looking Cardan shaft. I'm just going to move this one around in its position. A little bit difficult because the motor wants to come out. As you can see, if I focus in on this bit, and I shall point, you can see this is where the drive pins on the end of the shaft are engaging. So if I make sure that that is pushed all the way home, put that into its most extreme point of articulation, you can see that the drive pin is still nicely engaged in the slot on the drive cup on here, so there's no chance of the dimensions causing a problem. But that's not just the only thing. As you can see, it's a very different shape as well. Very good engineering practice for that, and I'm sure the YouTube experts will of course be able to tell you all about that and why it is. So here is the standard shaft, one dimension, or rather one thickness right the way through. It is quite flexible. You might actually remember that when I did a 43 teardown, I found that one of the shafts actually was bent. This is more rigid, but the thing to remember, if you make something more rigid, you also make it more brittle, so I wouldn't go hanging off it. It's certainly strong enough to take. As I say, we've run 250s and 2 Class 43s with these over 10 hours and been absolutely faultless. And you can see the change in not just the dimensions but also the shaping of it. That also translates to, so if I can actually get it, I think a hand actually is probably better. You should be able to see that the drive pins as well have got some extra webbing on, so they're built up slightly here towards where they join the shaft, and there's a radius on there that makes that stronger. It's a thicker shaft to begin with, and then it's got this very large moulding on here, and it has the same treatment on the shaft on there. Got a flattened end on here. If you watch the teardown on the 43, you'll notice at first I wasn't sure whether this was correct, but I mean, I think actually Hornby have actually done that intentionally on the 43 on one of the shafts. I've looked at some others since and they all seem to be the same. I mean, it doesn't really sort of make any difference. At first I thought it was, I'll be honest, I was looking at it thinking, oh, have they just been a bit slipshod with the way they made them? But no, that was me, I was wrong on that. So you're all desperate to know why, what on earth is going on here. Well, as every engineer will know, when something starts spinning, there are a few little tricks you can do to improve the performance of stuff and make stuff smoother. And so basically, it's incredible to think that something in this size will make a difference, but science works no matter what scale you're in. It works basically as a dynamic balancer. So that is actually smoothing out the vibrations in the shaft. It helps centralize the shaft in its positions, and it will also stop it from picking up on the sides. So you have got two slots on here, which are what these pins on the side of the cups engage in. If you can create a way of ensuring that the shaft will automatically self-center, that also helps stop that getting any pickup in there as well. So when you look at fitting these, Richard is now making these available on his website. I'll do a link across to his website, and of course do remember, as always with Highfell, one of the reasons why I do this is because I love the hobby, and it's just about getting information out. So that's why I've decided, you know, we do the like, do the subscribe, do the share, whatever. Get involved in the comments as well. Make sure, you know, people know about this if you think it's of value. I don't take anything out of this. My view is that it's a hobby, so we contribute to it. Also, it's the same for Richard. He charges, but if anybody knows how much engineers should be charging and people with that kind of equipment, then he's covering his costs, if that, to be fair. So I'll put some links in. When you get these shafts, they will come with full instructions on how to fit them. The big thing to remember is that the larger end, so the dynamic balancer, goes towards the gear tower, the drive cup, and the other end is the one that goes into the flywheel, which has got the drive cups machined into the brass flywheels there. Just before we'll go, we'll and pop one in, we'll have a little bit of a measure. So we're looking at these being 0.9 of a millimetre in diameter. That's the standard ones. And then I think I should be able to get my micrometer on here. Right, so we're looking at these being, on the thinner section, we are looking at being 1.312, so considerably bigger. And that's just on the thinner side, and then the balancer is that's going up to a chunky 1, 2, 3, 2.95, nearly 3 millimeters on the balancer diameter, and that is sufficient to be creating the effect that we want, which is to balance out the any vibrations. When it comes to assembling, say, remember, fat end goes into the gear tower, into the bogey end. Also, I would recommend, and I know Richard does as well, use some grease to lubricate these. When you're using grease on anything like this, or any lubricant on your locomotives, remember that you want to be using something that's plastic friendly. So with oils, make sure you're getting a light machine oil that is suitable for these types of things, or the correct type of train lubricating oil. For these, I've used some grease. I do a lot of cycling, do all my own maintenance on that as well. So I've never met anybody I would trust to build my bicycles. So this is red grease. It's actually the same stuff as if you do any car stuff. So red rubber grease is plastic friendly. Another one is the clear grease that's used on brake sliders as well. So that's how you can do it. And then all you need to do is add a little bit of grease. Easiest is probably if you pop it in the cup rather than on the shaft, and then you don't get it splattered all around. Sparingly, so don't use a huge amount. You want just enough so it'll coat it, but you don't want it so it's just going to spit it all out on the inside of the locomotive. So it needs to just have a little bit of lubricant on either side. Pop those in, motor on, and away you go. So it really is quite simple, quite straightforward. I'm just going to give you another little bit of a shot there of the two, so you can see them quite substantially different. And it's probably, for some people might say, oh, that's just overkill, but this is what happens when you start using proper engineering principles in devices, even as mundane or as simple as a model locomotive, but it is actually quite a complex piece of engineering, and it's worth doing it right. I mean, I think this route's absolutely fantastic, which is why I now have them. So hopefully you've enjoyed that. You've had a little bit of a glimpse inside. As I'll leave some links, and anything you want to say on the matter, do get involved in the comments, and look forward to seeing you on the next one. I think I must be due for doing some running and show you what's been going on High-Fell itself. We've been quite engineering heavy recently, with lots of locos and bits and pieces being pulled apart, so perhaps time to move away from the engineering department and get out onto the line and see what's happening. So I'll catch you on the next video. Thank you very much for watching, and thank you very much to all those people who subscribe. I think we're over 800 now, which is fantastic. I really am quite surprised. And do take care, and happy modelling.